So today we are going to integrate this 1 over t4 plus 4 with respect to t, and we can see that we have two terms in the denominator, and those two terms are t4 and 4, and both of them are perfect squares, which means that they can be written in the form of squares. So we will write them. It basically gives us the hint that a square can be completed in the denominator. So we will write t4 as t square whole squared plus 4 as 2 squared. So a square and b square terms are these two terms, and in order to complete the formula we need to write the third term, which is 2ab. So in this case it will be 2 into t square into 2, and because this term was not present in the denominator in the question, so we need to subtract that as well from the denominator. So minus 2 times into t square 2 times t square into 2. So we have 1 over first three terms make the square, so we can write it as 1 over a plus b whole squared. A was t squared and b was 2, so 1 over t squared plus 2 whole squared minus the last term was 4t squared, and 4t squared is again a perfect square. It can be written in the form of 2t whole squared. And why are we doing this? Cause we are doing this because we want to make this as a square minus b square, because that form is factorizable. So I've written 4t square as t 2t whole squared. So in the denominator it becomes 1 over t square plus 2 whole squared minus 2t whole squared. And the factors of a square minus b square are a plus b into a minus b. So 1 over t square plus 2 plus 2t, and t square plus 2 minus 2t will be the factors. And whenever we have factors in the denominator, we want to integrate that kind of expression, we basically use partial fraction resolution. And for partial fraction resolution we need to uh, we need to basically um, call those factors as denominators, make those factors as separate denominators of separate fractions, and we assume some numerator. So in this case both of the factors are quadratic, and both of these factors will be denominators of separate fractions, as you can see, and the numerators of those fractions will be at plus b and ct plus d. And we basically let the denominator such a way in such a way that the degree of the numerator is one less than the degree of the denominator, and it is because otherwise the numerator can be divided by the denominator. So we now need to find the values of a, b, c and d. For that we just multiply with t square plus 2 plus 2t into t square plus 2 minus 2t on both sides, because that is the LCM. So 1 is equal to this equation will become 1 is equal to at plus b into t square minus 2t plus 2 plus ct plus d into t square plus 2t plus 2. And now we multiply these factors to get the final equation, and that will be 1 is equal to at cube minus 2at square plus 2at plus bt square, and so on. Multiplication can be done. So from this equation we can make separate equations for different like terms, and from those equations we can find the values of a, b, c and d. So when I compare the coefficients of t cube on both sides, we get a plus c equal to 0, because on left hand side there is no t cube, and on right hand side we have two terms, and those terms are at cube and ct cube. So if we take t cube common, the coefficient will be a plus c. Similarly, when we compare the coefficients of t square, we get minus 2a plus b plus 2c plus d equal to 0. And when we compare the coefficients of t, we get 2a minus 2b plus 2c plus 2d equal to 0, and for constant we get 2b plus 2d equal to 1. So I've written this equation to this was basically equation that minus 2a plus b plus 2c plus d equal to 0, and we can multiply both sides with 2. And why am I doing this? Because um, I want 2b plus 2d, because we have an equation which gives us the value of 2b plus 2d, and if we multiply this equation with 2, the above equation, talking about this one, so uh, when we multiply this with 2, we get minus 4a plus 2b plus 4c plus 2d equal to 0. And from here 2b plus 2d equal to 2b plus 2d was equal to 1. So we get minus 4a plus 4c plus 1 equal to 0. And we get 4c minus 4a equal to minus 1 from this equation. And we have another equation in terms of c and a, so we can easily use these two equations to solve for c and a. So I'm basically equating the coefficients here. So in order for us to solve this pair of equations, we need to make the coefficients equal, and for that we need to multiply this second equation with 4. uh, so it will make the uh, coefficients of 4 equal, c equal. It will become 4c plus 4a, and the coefficients of c will be equal. So when I multiply this equation with 4, I get 4c plus 4a equal to 0. And this equation is the second equation, 4c minus 4a equal to minus 1. So both of these equations can be solved by simply adding both of these equations, because a has we can see that a has coefficient plus 4 in this case and minus 4 in this case, so these terms can be cancelled. So we are just adding these two equations, and we get 8c equal to minus 1. And from here we get c is equal to minus 1 by 8, because 8 was being multiplied on this side, so it will be divided on the other side. And we can easily put this value in a plus c equal to 0, which was the first equation. We put this value into this equation, and we get a is equal to 1 by 8. Similarly, we can use these values of a and c to get the values of other two variables. And the equation I'm using is 2a minus 2b plus 2c plus 2d equal to 0. So I'm just putting the values of a and c in these equations, in this equation. So a is 1 by 8 and c is just minus 1 by 8. So we get, after cutting, we get 1 by 4 minus 2b minus 1 by 4 plus 2d equal to 0. So the final equation is 2d minus 2b equal to 0. And we have an equation which is in terms of d and b, and that equation is 2d plus 2b. So that equation along with this equation, we can along with this equation we can solve those two equations to get the values of b and d. So here I have written these two equations. One equation was 2d minus 2b, and the second equation is 2d plus 2b equal to 1. So we can just add these two equations. So the coefficients of b's, the terms of involving b are just cancelled, so we get 4d equal to 1 and d is equal to 1 by 4 from here. And when we use this value of d in one of these equations, so I'm putting the value of d in this case 2d plus 2b. So 2b plus 2 times d, the value of d was 1 by 4. So uh, we can cut, so the final is 2b plus 1 by 2 equal to 1, and this 1 by 2 is being added on the left side, so on the right hand side it will be just subtracted. So 2b equal to 1 by 2. and b is equal to uh, this 2 is multiplying on the left side, so it will be divided on the other side. So we get b is equal to 1 by 4. So we have found all the values a, b, c, and d. Now we just put these values in our partial fraction resolution form and solve for the integral. So this was basically our partial fraction form. So at plus b over t square plus 2t plus 2 plus ct plus d over t square minus 2t plus 2. So the problem we face integrating this thing is that the derivative of t square plus 2t plus 2 is 2t plus 2. Okay, let me put the values first. So I'm putting all the values, 1 a, which was 1 by 8, b 1 by 4, c minus 1 by 8, and d 1 by 4. So I'm taking the LCM in the numerators. We get t plus 2 over 8, and we get 2 minus t over 8 in the second term. So t plus 2 over 8 and 2 minus t over 8. So this 8 basically just shifts to the denominator when we multiply t square plus 2t plus 2 with this fraction. It basically gets inverted. It becomes 1 over t square plus 2t plus 2. And so the 8 just multiplies with the t square plus 2t plus 2. And in this case, the similar thing happens, and it becomes 2 minus t over 8 times t square minus 2t plus 2. So we can take 1 over 8 common from these two terms. It becomes 1 over 8 times t plus 2 over t square plus 2t plus 2 plus 2 minus t over t square minus 2t plus 2. So now we need to integrate this thing because our function or our expression is equivalent to this thing. But we can see that there's a problem here, and the problem is that whenever we can integrate a form where we have an expression in the denominator, and its derivative is written on the in the numerator. But here in this case, the derivative of t square plus 2t plus 2 is 2t plus 2, but in the numerator we have t plus 2. Similarly, in this case, the derivative of t square minus 2t plus 2 is 2t minus 2, but we have a 2 minus t written over here. So we need to adjust these numerators in suitable form so we can use that particular rule of integration. So I'm now going to write these t plus 2 and 2 minus 2 in t in the form of those in the form of fractions. So I can write this t plus 2 over t square plus 2t plus 2 as 1 by 2 times 2t plus 2 plus 1 by 2 times 2. And we can just solve it to see whether this is equal to t plus 2. And this becomes 2t plus 2 over 2 plus 2 over 2. And the LCM is 2. So it becomes 2t plus 2 plus 2 and 2t plus 4 over 2. And when we take 2 common, we get 2 times t plus 2 over 2. So 2's get cancelled out. So we are indeed left with t plus 2. And it's easy to write this form when we take the numerator of when we take the numerator of one fraction as 2t plus 2, that is basically the derivative of the denominator. So we need to take the numerator of one fraction as the derivative of the denominator. And we can adjust the second term to get this whole expression equal to t plus 2. So I've considered, or I've written the derivative of the denominator divided by 2, and plus I've written 2 over 2 in order to get the equivalent form it equal to t plus 2. So 2t plus 2 over, we can write we wanted to write t plus 2 over t square plus 2t plus 2 in the form, in such a form that we can integrate. So we can write it as 2t plus 2 over 2 times t square plus 2t plus 2 plus 2 over 2 times t square plus 2t plus 2. And we now need to integrate these two terms. We can easily integrate this thing because the derivative of denominator is written in the numerator, but we need to integrate this thing separately, and you know in order to find this whole integral. So we know the integral of this thing, we just need to find the integral of this thing. So I'm writing the integral of this. So integral of 2 over 2 square plus 2t plus 2. So we can see that we can complete the square in the denominator, and by taking t as a and b as 1, because we have 2t here, so we need to make this 2t, and for that we have to take 1 as b. So it becomes a squared plus 2ab plus b squared. B is 1, and we need to make this 2. So 1 squared plus 1 is 2. So we get 1 over t plus 1 whole squared, because this was a squared plus 2ab plus b squared, which is equal to a plus b whole squared, which is uh, just t plus 1 whole squared plus 1. This is basically x squared plus 1 or 1 plus x squared, and we know that tan inverse of x has this derivative 1 over x squared plus 1.